this is the list of the problems. We are going to do these 6 problems. First, okay, let's go to do these problems. This is the problem say, find two positive integers, two positive numbers, x and y. So the x and the y. So x and y that you multiply, and the product is 185. Now the function that is the sum is the x plus y. And you want to find when s is a minimum. So this problem means that you can find two numbers. For example, 1 for the x and 185 for the y. And the product x multiplied by y will be 185. That this is the requirement. And the sum s will be 100, and the sum s will be 186. Maybe you can find another number. For example, the 4 and 185 divided by 4, the product will be 185. And the sum will be 4 plus 185 divided by 4. 185 divided by 4 is like 45 maybe, 45. Is 160 plus 20 is 180, 41. So is 45 is 46. It's around 46. So 4 plus 46, the sum is 4 plus 46 is around 50. This is the sum for these two numbers. So for which number, x and y, you will obtain the minimum sum. For example, if you have the 10 and 185 divided by 10, the product will be 185, and the sum will be 10 plus 18.5, or 28.5. So now the sum is smaller. So the question is for which x and which y you obtain a minimum sum. So how we do this problem? We need to minimize the sum, this function. But we know that x multiplied by y is 185. So the y is 185 divided by x. So the sum depends on x as x plus y. But y is 185 divided by x. And now we want to find the minimum. So we find the minimum happen when the slope is 0. So we found the derivative of s respect to the x, which is 1 plus the derivative of 1 divided by x, or x minus 1. The derivative respect to the x is minus x minus 2. Or minus 1 divided by x squared. So it will be minus 185 divided by x squared. And I want the derivative of x to be 0. So this will happen for each x. This will happen with 1 is 185 divided by x squared, or when x squared is 185 divided by 1, or when x is a square root of 185, which is approximately 13.6. So the x is 13.6, and the y is the number is here. The y is 185 divided by 13.6, and the y is 185 divided by the x by 13.6, which is 185 is inverse is 13.6 also. Okay, so the two numbers are 13.6. The x is 13.6. The y is 13.6. The product is 185 if you multiply, and the sum is 27.20, and this is the minimum sum. These are the two numbers whose minimum sum. If I choose, for example, the x equal 12 and the y equal 185 divided by 12, so the product will be 185. The sum of these two numbers will be bigger than 27.2. These are the two numbers. So you can see the power of solving these kind of problems. Let's go to the next one. Find two positive numbers such that the x is the first number and the second is the reciprocal of x of the first. So it's 1 divided by x. So this is the first number, this is the second number. So this is the first number, and the second number is the reciprocal of the first. Find is the reciprocal, and the sum is a minimum. So the sum is x plus 1 divided by x. And I want to minimize the sum. So I want when the derivative of s respect to the x is 0. And this is 0 when 1 minus 1 divided by x squared is equal 0, because this is the derivative of s respect to the x. So 1 divided by x squared equal 1, so x equal plus minus 1. So 1 equal 1 and the other number, 1 divided by 1, are two numbers, two positive numbers, whose 1 is the reciprocal of the other 1, 1 and 1, and the sum is the minimum. So what it means? That the sum here will be 1 plus 1 divided by 1, that is the reciprocal. The sum will be 2. So what it means, this is you choose another number, let's say 1/2. It's a positive number. What is the reciprocal? 2. What is the sum? The sum will be 2 plus 1/2, which is 3/2, which is bigger than 2. You may choose another two numbers, maybe 1/3. 1/3 and the reciprocal 3. The sum will be 3 plus 1/3, will be 27 divided by 3 plus 1/3, or 28 divided by 3, which is bigger than 2. So whatever you choose, the two numbers that you have to choose in order to have a minimum for the sum, if one is the reciprocal of the other, is the 1 and the 1. Of course, there are positive numbers, so here, when you solve it, x equal plus 1. Okay. Now this problem says, find the point on the graph y equal x squared, y equal x squared, this point y equal x, a point that is closer to the point 2,2, 1/2 is here, 2,1/2. And when x is 2, y is 4. So let's go to draw the function y equal x squared. When x is 2, y equal 4. And this is the point on what it's asking is, search for all the possible points, for all the possible distance between the point P and the graph. The graph have the point x, x squared. This is the point of the graph y equal x squared. And what it says, try to find the point that have the minimum distance. For example, the distance between this point and this point, this is 1/2 of 8, and this point is 4. So 4 minus 1/2 is 3.5. So it's a big distance, so here there should be smaller distance. So what it says, find this point, x and y. Find the point x and x squared, whose distance to the point 2.1/2 is the minimum. So the distance squared is x2 minus x1 squared plus y2 minus y1 squared. So in this case, the 2 points that I have is x1, y1 is the point 2.1/2, and the other point that I have, x2, y2, is the point x, x squared. So the distance d squared is 2 minus x, x2 or x2 minus x1, or x minus 2 if you prefer. It's the same because it's going to be a square, x minus 2x squared plus x squared minus 1/2 is square. And I need to minimize this equation to find the x for which to find this x for which the distance here is the minimum distance. Wow, it's powerful, this method. So what we will do, if the distance squared is a minimum, if the distance is the minimum, the distance is the square root. The distance squared is also a minimum. So this function d, let's go to call d equal d squared. D is a function that depends on x. So if I find the derivative of d respect to the x, I put it equal 0, I will find the x that makes the distance minimum. So what is this derivative? So the d that is the d squared is x minus 2 squared plus x, sorry, it's not x squared. Okay, let's go to write the equation correctly. The equation here is x minus 2 squared plus x squared minus 1/2 plus this minus this square, s squared. So what is the derivative of x minus 2 squared? So the derivative of the respect to the x is 2 times x minus 2. And the derivative of this is 2 times x squared minus 1/2 raised to the power 1 by the derivative of x squared minus 1/2, which is 2x. And this should be equal 0. So I have this expression 2x minus 4 plus 4x cubed minus 2x equals 0. Wow. 2x minus 2 here is x squared minus 1/2 squared, I said. I don't know why the raise. 2 times x squared minus 1/2 multiplied by 2x, perfect, is 2x minus 4, 4x cubed minus 2x. So this 2x go home, and 4x cubed minus 4 equals 0. So x cubed minus 1 equals 0. So x cubed equals 1. So the x is 1. If I'm looking for the positive number, is x equal 1. And y equal x squared. So the y is 1. So the point 1, 1, this point, the point x equal 1, y equal 1 is the point that is the nearest point, the closest point to the point 2, 1/2. That's the result. Now we go to problem 4, that is more or less the same problem. You have the graph of a square root of x, which is something like this. Y equals square root of x. For this x, let's say 4, the square root of x, the height is 2. For this x1, the height is 1, because the square root of 1 is 1. So I have the point 4, 0. Oh, the point 4, 0 is this point. And I want to find the nearest point, the closest. So which one will be that is on the curve? This one, or this one, or this one? Where is the nearest point? So I will say the distance d squared is, what are the 2 points? The first point is x1, y1, 4, 0. The second point, x2, y2, is the point unknown x. I don't know if this is the x, or maybe this is the x. I don't know which one is the x. And the y is the square root of x. And the distance squared that separates 2 points is Pythagoras theorem. Is x minus 4 squared plus square root of x minus 0 squared. So the distance squared is x minus 4 squared plus the square root of x plus x. And I need to, and this function, the function that depends on x, I want to minimize. I want to minimize this function, the d, the capital D. So capital D is d squared. So how I can minimize the function? Do the derivative of d respect to the x, and do it equal to 0, and you will find the point. 2 times x minus 4 plus 1 equals 0. This is the derivative of this function. So it says that 2 times x minus 8 plus 1 equals 0. It says that 2 times x equals 8 minus 1, 7. So x equals 7 divided by 2 is the point. 7 divided by 2 is like 3.5. So the closest point is around here, 3.5. And the y is a square root of 3.5. So the point is 7 divided by 2, and the y is the square root of 7 divided by 2. And this is the point that is the minimum distance from 4, 0, from this point, to the point in the curve, this point, 3.5. So this is the point, this is the point that is the nearest one. If you move a little bit here, it would be greater distance. If you move to this direction, it will be also greater distance. This is the distance, the point whose distance is the closest point. It's the closest distance. Okay. Okay, let's go to do this problem that is a problem of optimization. You want to do a fence, and the fence is only this fence, y, x, and y. You don't put any fence here. You don't need. Maybe there is a, You don't need it. Okay. And you want to minimize the amount of fence. So the fence, the length of the is 2y plus x, and you want to minimize in a way that you maintain the area here. The area is x multiplied by y, and the area should be 245,000 square meter. So what are the dimensions of this? What is the shape of this rectangle that you minimize the amount of fence and you maximize the amount of area? Well, you maintain the amount of area the same one. What you minimize is the amount of fence. So for the second equation, I have the y equal 245,000 divided by the x. So the length is 2y, or 2 times y, or 2 times 245,000 divided by x plus x. So the length L is 490,000 divided by x plus x. And I want to minimize this function. I want to find for which x the value of the function is the minimum. So I do the derivative of L respect to the x. What is the derivative? Is minus 490,000 divided by x squared, because the derivative respect to the x of 1 divided by x is minus 1 divided by x squared, plus the derivative of x, which is 1. And these have to be equal 0 to find the slope 0, to find the minimum or the maximum. So if you solve here, you will have 490,000 divided by x squared equal 1, or x squared equal 490,000, or x equal square root of 490,000. So the x will be 490,000. So the y have to be also square root of 490,000, because the x by the y, the x by the y is 245,000. So the x is square root of 245,000, and the y, let's go to correct the y, and the y is equal, is here, the y is 245,000 divided by the value of x. So the y is 245,000 divided by square root of 490,000. So if you take now a calculator, you can find these two numbers. Let me take the calculator just a moment. So the square root of 490,000 is 700, because 700 by 700 is 490,000. And here, this would be 350, so I found the dimensions of the rectangle. The rectangle should be like this, 700 and 350. And now I have the biggest, I have the rectangle that have the smallest length of fence. The fence that they will use is 700 plus 350 plus 350 will be 800, will be 1,400. 1,400 is the length, and the area is 2,450,000. And this is the dimension that makes the area the biggest area. If you take another x and another y that have 245,000, any other x and y will have a smaller area than the one that we have created here. Let's go to the next problem. Okay, let's go to do the last one. It say the sum of the perimeter of an equilateral triangle. An equilateral triangle have the size, let's say A, and A, because it's equilateral. The square have the side B, 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 B. Okay. And it say that the sum of the perimeter is the sum of all the sides. It would be 3 times A plus 4 times B. And this sum, the perimeter, is 10. Okay. So what it says is find the dimension of the triangle and the rectangle and the square that produce the minimum area. So the area is the area of the triangle plus the area of the square. The area of the triangle is 1/2 the base by the height, and the area of the triangle is B by B. Of the rectangle of the square is B by B. So this will be 1/2. Now the base is A. The height, because this is 30, because all the angles of an equilateral triangle, they at 180 should be 60. So this should be the height, should be A cosine of 30 divided by 2 plus B squared. Okay, so I have that the total area is 1/4 A squared cosine of 30. Now sine of 30 is 1/2. So cosine of 30, because sine of 30 squared plus cosine of 30 squared is 1, cosine squared of 30 is 1 minus 1/4, is a square root of 3 divided by 2. So square root of 3 divided by 2 is cosine of 30. And this is the area of the triangle plus the area of the rectangle, B squared. But I know from this equation that B will be 10 minus 3A divided by 4. So I will write the area as a function of A. So it will be 1/4, 1/8, A squared, square root of 3, plus B squared. But B is 10 minus 3A divided by 4 squared. And now I want to find the derivative of A respect to the A, to the size A. And equal 0 will give me which one is the A that produce the minimum area. And knowing the A, I will know the B. So I leave you to do it. You comment me if you can do it. Okay.